Okay, thank you. So yeah, my presentation is going to be a bit less hands-on, a bit less technical, more like yeah, we built an internet spawner application and how we what we did to get there. I'm going to skip like the whole the in detail Docker kind of things that you're talking about. So that probably like fit each other good. So good evening, everyone. My name is Bryan. I've been working at Lively for about 4 years now. I started here like 4 years ago as a backend developer, and I was like the 5th person, I think around the 5th or 6th person. And yeah, I grew with the company. Did well part-time first, so I did way more and more ops kind of stuff over time, where we had like more employees working here. So ops was getting bigger and bigger, right? So that's me. Yeah, of course, I'm point man right now at Lively for all the ops related kind of things. And yeah, Peter already said like we are Lively. We created like web and mobile apps to digitize business processes for our customers. Okay, so today I'm going to talk about a little ops kind of project. We're doing a lot of like web application and things, but this was specifically an ops project we did a bit ago. And yeah, it was an application for a customer I will be calling Joe today. And we made an application for him before like the whole spawner thing. We made some kind of intranet application that I'm going to show you in a bit. And he really wanted to like provide that internet application to his customers, but he had like more than one customer, right? So he needed a way to provision like a server or something with the spawner application, with the internet application. And today we're going to look at how we implemented that to make it all work. Of course, he wanted to do that with minimal effort. Joe is a bit technical, but not that technical, so it was harder for him to like go through the whole process without us building an abstraction layer on top of that. So this is an example of the internet application. You can see a couple of things here. On the left side, for example, they can manage groups with users, and in those groups you can link documents and talk about stuff. You can name the group anything you want, so that's pretty generic. There's also events, basically same kind of things like group, but with a date, a start date, end date, all those kind of things. Then we have articles, and of course colleagues are in there. It also supports built-in chat, so we made real-time chat in the application, so colleagues can chat with each other and inside of groups. And there's, in this case, this is the dashboard, so there's like a timeline of all the updates that are being done in there. Next, we also built a mobile application. This is the mobile application that's mainly focused on notifications regarding the chat. So you can't do like all the group and events editing, but you can chat with people. It's built in React Native for mobile of course, Android and iOS. So yeah, that's basically it. It talks to Meteor using WebSockets. So coming to that, a little bit of background on what the stack looks like. The main web application is built in Meteor. Yeah, it was built a bit ago. So at the time, Meteor was like the whole hot thing, right? That provides like everything you need. And so yeah, we created that in Meteor, and of course, I wouldn't be talking about this if we didn't use Docker. And especially for Meteor, we saw over time that Meteor has some bit of a pains to sometimes it just crash on build because it's out of mem or whatever. It's really strange. Yeah, there are seg faults and you name it. So Docker was really a really good solution for us for that, because we know when the application was built once, we always knew that if we were going to run that application somewhere, we didn't need to build it another time, and we were 100% sure that we were able to deploy it. Next up was Ansible. We use Ansible as the infrastructure code, like how to provision the servers. Coming to servers, we rent our VPSs at DigitalOcean, and we provision that with with Ansible, of course. And we started off with like a pilot for this Intranet application, and therefore we just had like one version, right? So we built a whole provisioning code just to provision one server with this Intranet application that he could use for that like Joe could use for his pilot, and just verifying with his customers whether or not this was going to solve the problems they had. Okay, so the whole challenge here is build an application that lets Joe spawn an instance of his Intranet application with minimal effort. So yeah, the minimal effort part was really important for him. So what now? Okay, so of course we need to build an application for Joe to manage his instances of this Intranet application. And every instance that we're going to spawn will need some kind of configuration, like for example a URL. In this case I took domain.intranet.io as an example. Of course it needs a place to run. It can basically run anywhere, of course, because it's a Docker application, but we need to somehow make a place where it can run. And definitely it needs custom environment variables, like you say, talked about a lot. For all the different customers, they all have different like configuration they need and things like that. And of course, I probably think everyone here knows about Mr. Kubernetes. He can do all this for you, but we built it a while ago, and at the time we had rather low budget, and we didn't have much experience on Kubernetes. So it wasn't really an option to like go the full learning curve on how Kubernetes works and how we need to implement that. So yeah, money was a bit of a problem, as always, of course. Okay, so we decided to stick with the existing solution that we had, like to provision this service with Ansible. But to do that, we had to make like our provisioning scripts more generic, so that we could provide it with configuration like based on the environment that we were going to spawn. So to do that, we made an abstraction application on top of that. This is the example of the spawner application. Here you can see how you can create, for example, a different environment. It was built in Laravel. There were a couple of reasons. Does anyone of you know here know Laravel? Or? Okay. Yeah, it's a PHP framework that has like a shit ton of stuff already done for you. So yeah, you don't have to reinvent like a ton of wheels that you have to in JavaScript land. So that was basically one of the reasons, was that based on the fact that we were on low budget, and I knew we would stall the project just like right after it, and there wasn't enough continuity. Because our own stack, our own custom stack is like Node.js TypeScript, but it evolves so fast that I know if there's no continuity in the project, it would be legacy really fast. Because we needed continuity to improve on the stack all the time and stuff like that. And it's easily, there's a service called Laravel Forge that easily lets you deploy an application built in Laravel. So that was like a bit of a no-brainer. Okay, so the spawner application, originally the provisioning was done using Ansible, of course, and integrating this whole thing like into a web application, or like in this case a Laravel PHP application, didn't make too much sense, because you have to do like a lot of things, right, to run Ansible, and then you have to like somehow code that you run a shell script which runs Ansible, which does a lot of things, and that didn't really make sense to put it inside of the spawner application. So we needed something for us to run Ansible, which didn't run inside the Laravel application. So I thought, let's call one of our old friends. I'm wondering if somebody here knows who this old friend is going to be. Chef? Chef? No. Huh? No, it's not. It's not the not the Ansible-like thing. We will still be using Ansible. So it's not a replacement for that. It's another old friend. Hmm? No. Close. Somebody else? You know it, Peter.
I know. If there's a hint, he looks like a butler.
And he's an old guy. Yes. Okay, so yeah, that's of course Jenkins. Jenkins is of course able to run these kind of things and do these kind of jobs in a really sensible way. It's open source, so we could just download it, run it with Docker, of course. Today we're going to give him some superpowers. So we have Super Jenkins, just to give him some kudos. Because like Jenkins is, the old kind of guy, which tends to be really weird to work with, but if you use it for quite a bit, it's a pretty good thing, and you can run it on premise or whatever. So so to put everything together, this was kind of like the idea on how we were going to create a solution for the problem we had, like with spawning the applications. So again, here you have the screenshot. Like Joe, the application owner, just had to fill in some contact details of the person that it was just for like for him to know, which of his customers was managing this server. And a company, of course, that has like the main important parts are the domain and the slug, like the subdomain part. So he had some kind of application like domain.intranet.io, of course, and he just provided the domain name here. But yeah, what happens now? If he presses like the save button, what happens then? But that's what I would like to take a look with you at. First thing is the application. So this is the Laravel spawner application. That hence the logo on the left side is the Laravel logo. It will request a droplet at DigitalOcean using the DigitalOcean API. So yeah, that was really easy to implement. That's the first part. Second, the application starts polling the DigitalOcean API to see whether or not the droplet, like the server, is ready. It has an API, or it has an IP. That basically means that it's ready to start configuring it. Then we call we call an endpoint on Jenkins, which triggers Ansible to provision that specific host. Besides that, we use the DigitalOcean API to create a DNS record. Like the domains we use all have their name servers pointed to DigitalOcean name services, and that way we can create the domain and also provision the server. And then we poll that. So we're going to poll the application on the domain to see, like, is it actually running the application on that specific domain? So is it, just to see whether or not it's ready. And then there are also a couple of more health checks that like check whether or not the application is not only serving like the HTML files, but also making sure that the backend is working correctly. And if so, then we send an email to Joe that the application is ready. So yeah, that was basically it. Like that was the part in where we just spawned an application, and we were happy. We released the MVP. Joe was happy, but suddenly he called me and he said like, "Hey Brian, I misinputted the URL. Can I just destroy this, or can I just change this?" Or and of course, like destroying that means that we have to implement something for that, and it was bound to happen at some point. That he was going to delete some of his servers or spawned instances. So about destroying such an instance, we go through this flow. Basically, it's queuing a snapshot of DigitalOcean. That's basically like creating a backup, right? Because you never know what Joe does. So if he all of a sudden just destroys some server that is running in production, then at least there is some kind of snapshot to get back from. That, of course, we delete the DNS record, also using the DigitalOcean API again. And lastly, we can just use DigitalOcean API again to yeah, send an event for deleting the droplet. There is no polling in here. That the main reason for that is that if you send a API request to DigitalOcean by saying make a snapshot, and then you immediately send a request for delete this droplet, it will always wait for the first event to finish and then do the second. So we can just fire the two just after each other. So deleting was like a really easy solution to implement. And then we had, of course, had one last thing that was about backups. So for backups, we also used Ansible, like the whole we kind of created an Ansible playbook to make a backup or restore a backup from a specific environment. So this is what the application looks like. Like this is kind of the admin-ish interface for a spawned instance. And you can see here, these are all the backups that were created for, well, company A.Intranet. It's all different, yeah, different instances. It says company A and company B, but it of course can be like a staging environment for customer A and acceptance environment for customer A. And he can then just restore and make backups on the fly here, and that triggers a Jenkins job that actually makes the backup and does the restore. Yeah, so that's basically my really quick talk compared to just say. Yeah, if you have any questions, feel free to ask me. I'm gonna make a note that I have a hearing impairment, so probably one of my colleagues from Lively is going to like help with understanding the question. But yeah, that's it. Any questions?
So you showed the provisioning, but usually you're running only one instance of the application, or was there kind of load balancing to scale in case of usage?
Yeah, the provisioning is now done just for one server because yeah, it's an internet application and his customer aren't like the super huge customers yet, so it doesn't need too much scaling by now. And we are also starting to look into Kubernetes and stuff, and because that's probably more of a fit, in case yeah, it has to be more scalable and things like that.
Sorry if I missed this, but what handled the provisioning of the domains?
Domain?
Yeah, you said that.
Oh, the domain.
Yeah, the domain.
Oh,
it needs a domain, right? So
yeah, we have the domain points. The name servers of the domain point to the DigitalOcean name services, and they have like an API for domain records, and so we use that to just set like the A record, the senior record, and stuff like that. Yeah, exactly. That's why it's always a subdomain of a major domain, and the domain was a selection field. So there are a couple of predefined domains they can use. Yeah, one is .nl and one is .com, right? That's the only two that are existing right now. So that, yeah.
You mentioned Meteor as technology for building it.
Mm-hmm.
Do you have it backend, the database, in a separate container, or is everything together?
Yes. Like everything was Dockerized, so we had Mongo in Docker. It handles Elasticsearch, so it's also in there, and of course, like the application itself is in there. So I think there's 3 containers on each host, and the hosts are like only provisioned to run Docker. There's not like anything else that is being done there, which makes the move to Kubernetes like a lot easier, right? Because it's technically it's just like Ubuntu 60.04 with Docker installed, and then we install we run all the images that we need.
Yeah. What were you running inside the Jenkins jobs? So
documents is your custom code that handles the reading?
Yes, inside Jenkins there's a custom container that we built that has like everything we need from Node.js to Ansible, of course, because it's going to run Ansible, and that's like the main things that are in there right now, and it just checks out some repository that has the provisioning code and then runs Ansible playbooks with the configuration that's in Jenkins. So that Jenkins job has some build parameters, and those build parameters are sent from the spawner application that determines the build parameters that's sent to Jenkins, and then Jenkins can create the whole configuration like inside that job and then run Ansible on the specific host. And the host, of course, is inside. That's known inside the spawner application itself. So that knows this domain is, or this subdomain, right, is running on this host because those are linked in the database. Any more? Oh yes.
You do application monitoring as well?
Do we do application monitoring as well? I think we don't do application monitoring right now. We do the DigitalOcean like infrastructure monitoring, but we don't like monitor the application runtime. We never came like to the point where we implemented something to like we could use one of the X amount of services online and just send it there, but yeah, we never came to the point of doing that. Sorry?
What do you use Elastic for?
What did you use Elasticsearch for?
Oh, what did you use Elasticsearch for? That was for searching like through the articles, groups, all the documents in there, because it also parses like PDFs, Words, whatever, and that's also part of the search engine. We didn't use Elasticsearch for monitoring or anything like that. It's just for search, actually. So.
And maybe for the logging or for the monitoring, it might even make sense to when you're registering the domain to also register this domain to, for instance, status cake.
Yes, of course.
Like a service that we use to monitor if the applications are still running. Yeah. And then you would need to register and deregister it.
Yeah, exactly, yeah. It shouldn't be too hard to do. It's just like some hook inside the application, right? At the point where we created the application. And we could, register with any monitoring SaaS or whatever. We can even like make a job in Jenkins that checks it like every year, now or then, but it's probably not like the best solution.
What do you think would be the hardest challenge when you would migrate this setup to Kubernetes?
Understanding Kubernetes. I don't think there are that much of because like everything is Dockerized already. You mean this whole setup? That's basically going to how are you going to connect to Kubernetes and like the whole authorization thing and doing stuff in namespaces and that's basically like all the Kubernetes things are going to, but it shouldn't be that much of a problem given the fact that you know like how Kubernetes works in and out. Then it shouldn't be that hard to switch this to Kubernetes.
Because one of the big parts that the client wanted was that every server was completely isolated. So all of the data of this person is on this server, and you know where the server is, and doesn't have any shared resource with other clients. And in Kubernetes, you would then use the namespaces to isolate these separate parts, right? Yeah,
probably. Yeah, or every of his customer could have some kind of different cluster or something like that. But yeah, that really depends on what he's going to want.
You have a mobile application? Is that part of the build as well?
The mobile application is generic. So when you log in, it first asks you like what the domain is that you're logging into. So that feels more like a multi-tenant app, but it actually isn't, because it depends. it uses like the URL that you provide to determine what the endpoint is, because the endpoint is always running on that same host.
Just Slack.
Hmm?
Slack also does that same.
Yeah, yeah, exactly. Okay.
Was it written in Electron or something like that? Was it in Electron or something like that? Or React Native?
Oh, what it's yeah, it's built in React Native.
And why did you use the multi-tenant approach? Because what I see, every customer has its own instance, but why didn't you use the same instance for all the customers?
Yeah, that's basically what Peter just said. Like they really wanted isolated environment.
Publish updates for all the, for example, I need to add an extra field. How do we do that?
That's a good question. The currently like deployed version of the application is kept in Jenkins, so Jenkins knows like what the most recent stable version of the application is, and you can, from inside the spawner application, you can request a redeploy, and that will just redeploy like a new Docker image of the application. But there is no way to, it's not automated. Yeah. Because automating it would be too risky, I think, at this point. So.
Yeah, how do you manage this if you're updating any of your application and you've got state to be migrated? How do you manage migrating the state? Is that like a manual scripted process?
Yeah, we have migration files for that. I think it's just mostly that we write some kind of piece of code that will run on startup that is going to migrate something in Mongo if there is anything to migrate. Yeah, that's basically it.
I wonder if we have another customer like Joe, then would we build a trial on Spawner?
What? The last part?
Would we build a trial Spawner? Another customer like Joe.
Would we build yeah, probably. Yeah.
One layer deeper.
Yeah, yeah. Inception. Okay.
Thanks.